Alright, this is CircuitRepair Augusta, and today we've got a couple of repairs, but for this video just going to do something a little different. Actually ran into a customer while out in town, and they needed a fix for their headphones. These were some pretty decent quality headphones that they got from, he said it was a coupled purchase or a bundled purchase with their phone, and they got the LG V20 or 30. And so as you can see, these are some Bang & Olufsen headphones, which are pretty high quality, so it was a nice gift to come along with the phone. But shortly after he got them, the jack broke. Now I've already prepped this to find out what I was going to be working with, and this is where you can see from the video that this is a little bit different, and this is the first time that I've actually done this on a set of headphones where it's using multi-stranded enameled wire for each of the circuits. So we have, in this strand, we have red, which I want to say is left audio, green is right audio. This should be our ground. And then here we have mic, which is actually the white wire underneath those copper strands. And those copper strands should be our ground wires for the microphone. So this ground and this ground will go to the ground pin, and then we'll wire up mic and left and right audio. Well, actually, we may actually start with that bottom-up gesture, so mic may be first on our list. Now, earlier I had already started untwisting, and I've kind of marked off an area here if you're wondering what the tape is, so that I keep this as I'm looking down in the secondary camera's field as well as in the mic camera's field. But this is just a little part that I picked up, and I've got a bag of these. As you can see, it unscrews, and then what we're going to do is take the customer's wire after already having pre-stripped that and separated those. So we're just setting it up so that when we feed it in, that wire is now ready to be received and enclosed. If we wanted to make this really long-term sturdy, we could add some type of an epoxy down inside of this after we seal it up, just so that that wire is bonded in place and doesn't transition. But it should be strong enough with the weld joints that we're going to put on that we're not going to do that, and that'll make it more serviceable, because we actually had to cut away more material last time because it was bonded all the way through. So if you do have to make a repair, you end up losing about that much of your wire. But again, having the epoxy there is going to make that bond stronger and less likely to break, so we may leave it up to the customer to decide if he wants it for future serviceability or if he wants it to be as bulletproof as possible. So now for this, again, the way this works is you've got left audio, right audio, ground, and then mic. And these can actually be slightly different for different proprietary configurations, but the fact that this was made for use on a cell phone, it should conform to a standard. So the first order of business, again and always, will be to put on some gloves. And I usually always forget until I get started, and I've got to kind of wash my hands off and then put gloves on. So doing these videos has helped to kind of remind me to get there before that point. We're going to go ahead and pre-tin these contacts. So we're going to add some flux. And I've already set up my tip for this particular job using an extremely fine tip. Forget the exact model number. It's making it a little bit easier to see by letting some of that flux get hot and drain away. As you can see, that sticks nice and easy. And I made my markings, but I still allowed myself to get a little too high, so we were kind of in the corner. I've adjusted that now. Should have a better viewing angle of what's going on. We're going to take this away because we should have plenty now. We're basically just going to spread that solder over the contacts. I'll add this to down here. Alright, and that should make it nice and easy for those to be received. And now part of my tape setup is to kind of help me, and you can also use helping hands. I'm just kind of taping that down in place so that the wire isn't a pain in the butt throughout this entire process. And I've decided to go ahead and start from bottom to top. I think that's going to be our easiest for this. And we need to come back over. And there we go. Alright. So basically just unraveling this ground here. We're going to leave enough slack so that we know we're not going to end up making contact with those ground wires to the mic pole. And that should be plenty. I'm just going to use a razor blade to kind of mark it. Let's go ahead and just nip it. So the top line was our distance, or max wire length. And this bottom line we made, that is the amount we want to expose, making sure we've got good continuity on that wire. And this little sheathing will actually burn away. I could just do it by just applying contact, but I wanted to try to get some of that out of the way so that we didn't have the gook. Alright, and then now that we've done that, the next step will be to apply some solder to it. We don't need a huge amount, we just want to get a nice coating on that tip so that when we touched it to our pre-tinned area, it's just going to tack right on. And again, the solder that I'm using is what's called RMA solder, which means rosin mildly activated, which basically is that main active ingredient in your flux, and it's already been put into the solder, which is one of the reasons why it works so well. There is fiberglass in these lines. It's part of their insulation. It does make them a bit of a pain to work with. But it certainly doesn't make it impossible. Alright, so probably going to use the tweezers here and work more with our wire and hope that that just kind of stays still. There we go. And so what we're going to do now is just check and make sure none of those wires drifted up from the ground side. And just to make it a little more permanent there. To give permanence to my peace of mind, that those wires won't kind of back out from their little up and around and then somehow make contact. And we are going to trim these away once we get ready to mount them to that back ground pin. And now these are direct wires, but as I said before, they are enameled. So the fact that they touch is not going to create a continuity issue. They have a thin, pretty strong layer. It can be scratched, it can get overheated and melt and cause a bridge, but if that's happened, something else has probably gone wrong. Alright, so now we want to do our left and right audio. So right audio should be our next in line. So we're going to bring this around. One second, I moved something and wanted to make sure I was in camera. There we go. We weren't in camera completely. So we want to make sure we're just kind of working up the chain here. Otherwise, we'll create more work for ourselves. Alright, so this area here, and in my experience, the fastest way to do this is to just kind of make your mark. Now that we've made it, we know where we want our solder to catch at. So as you can see, I've bent the red wire at its mark. It's the next one to get soldered. Now for these enamel coatings, you definitely want to add some flux to it. It helps to transfer that heat because we're basically going to be melting this enamel away using a high temp. I believe this is 350 degrees C is what this enamel is built to withstand. So we've got to bring the tip above that if we want to break down that coating so that we can get solder on it. As you can see, that took right to it. And we're going to move some stuff around here. Let's get the tweezers out. So this is where these stranded units become a pain in the butt. It's not just grab a little simple insulated wire and go. Nope, they had to wrap a bunch of strands around everything. And this is where manufacturers do have the advantage. They probably have some special machine that was fabricated exactly for this purpose. It can do this very, very efficiently. Unfortunately, that machine's expensive enough to operate that repairing is probably not an option for them either. So this is where you go back to the old school hand method. It's cheaper for them to just keep making them than it is for them to go back and fix them. It's cheaper for the customer to have it repaired. And I might just be nitpicking here. Alright. But I'm trying to get this as orderly as possible. Alright, because that's twisted around, I think that's probably as good as we can get it to get it out of the way. It allows us to take this little fiberglass here. We can roll that over the back and take our little red line and bring it up and around so that it's not twisting on any of those wires. And they are sealed, but this just again helps to keep it orderly. In my opinion, helps to reduce friction, and friction could eventually cause those coatings to wear down. And we got out of scope again. In fact, I'm going to add another piece of tape just because it'll help me stay in view a little bit more. Been going through a strategic buying spree where I'm upgrading some of my equipment. I made a decision to get a camera for the streaming purpose that is probably not the end-all be-all camera for the main one, but it is what I wanted to move forward with at the time. One, it was a little bit less money. Two, it had a stand on it which is really for inspection. I have my old camera on that now, however I had to send it off to a machining shop because something the manufacturer did just really made it a pain in the butt. The way they threaded it, and it's supposed to be able to stand upright with the microscope. You know, basically you would think that would be a pretty standard configuration. You'd like your microscope to be in a straight down view or a top down view. Not the way this one works. It's actually on a permanent angle, and their solution to allow you to put it straight down was to put a screw, or like a grub screw, on the threading. But as soon as it gets enough weight, that grub screw eventually weakens and it spins counterclockwise, allowing the camera and its lens mechanism to slam down onto the workbench. And eventually that's probably going to break something. So I decided that the machine shop is going to put some threads on it. They're also going to machine out another anchor point on the horizontal base. And when I do get that back, I'll make a video of it and show it. And to be honest, the manufacturer should add these things in. It would cost them almost nothing to do, and it would make customers a lot more happy with their product. Alright, so now we've got 2 of our 3, and that's just that little fiberglass. You know, these joints don't have to be super pretty. You definitely don't want to have a lot of slack in this line. We're going to come back through and we're going to remove that. But we just want to make sure we have a good solid weld at each of these points. And then, like I said, these ground lines are going to come back, and we're going to tap those onto this back here. And again, we were sliding up and out of view. So let me reiterate. We're going to pull this area and cut it away. We're going to leave just this part. And then what we'll probably do with this green line is we'll come up and over. In fact, we'll go ahead and cut that red away. We're going to come over with this green line, and actually there's plenty of clearance. I think we may just lay it on top, just because when we cut this, depending on what I get here, I may loop it over this way. But let's go ahead and cut it. What we're going to try to do is use this to get some pressure and then seal that down. And that worked out nice. So again, these are a pair of headphones that cost $150 still today at retail. The customer did get them for free with the purchase of their phone, but I think he said it was something like weeks after he got it, this part actually snapped and broke off. Now, it could have been user error. I doubt that it was probably manufacturer defect. It could have been though, but it was more than likely, you know, we take our headphones out for our phone and then we're using them. And when we're done, we put them away and stick them in our pocket, and then probably set down on an uneven surface and caused it to break off. Sucks when it happens, but it happens. Alright, so the last one we need to attach here is our left side mic, or left side for the headphones. Remember, mic was the bottom, right side, left side, and once we do that, we'll be pretty much done. Now the question is do we want it this way? But I think just to reduce any interference, I mean, we're still going to get some crossover there, but we're not going to be laying on top of the bulk of that signal line. We'll come up over this way. I think with this one, because it's the last one and it's on the top, we're still going to pre-tin it. So I'll say we could tin on the bottom there, but just to make sure it stays nice and clean and tidy and we don't get any out of control solder or flux, we're going to do it off to the side like we normally do. You can see it's already starting to take form a little bit, and we pretty much have a soldered line there. I'm going to make sure that it flows through to all sides. And these wires are super thin. I don't know what their individual diameter is, but I would have to imagine that they're probably somewhere in that 0.001 millimeter. And so they are quite fragile. It's not far beyond their enamel seals temperature that you can heat them to the point where with a little bit of dragging of that soldering iron that they will splinter and tear apart on you. And you definitely don't want to lose the amount of wire spacing you have, which is why I try to give myself a little bit of slack, because if you underdo it and lose something, you're going to end up having to restrip and provide yourself that extra room, and you're going to shorten the overall cable length by having to redo it. So what do they say? Measure twice, cut once, and then in this case, leave yourself a bit of a buffer. I'm doing this backwards just because I guess, and see, that's what we don't want to do, but that I can scrape away. Okay, I might have to change. Even somebody that does this all day gets caught up in their own preferences, and that's where I'm right-handed, so I tried using the tweezers earlier with my right hand, which once I got everything situated meant I couldn't change, which left me trying to solder with my left. And basically it was me playing soldering twister over here. I had my arms crossed and it just wasn't comfortable. As I said before, you want to adapt your project, what you're working on, to you, not you to it. Otherwise, you'll probably run into an issue like that. Alright, so I've got it fairly adjusted the way I want it. I'm just going to hold that there. Basically what I was trying to do is take the wire and shape it to where I wanted it to be. And now we're a little too close, so we're going to make some adjustments. And sometimes your adjustments do that to you. Alright, come on. There we go. Now I just got to make sure that we're not making contact here, which I think we are going to be. So we need to fix that. And then we'll be just about perfect. There we go. And so the technique there was basically we're using thermal loss. I know I didn't want this side to move, which is why I gave a bit longer of a solder bead to that area so that I could wrap it over. And I knew that that would give me the ability to, if I get this side bonded the way that I want it and kind of laid it down, or vice versa, if I'd gotten this side bonded but this side was all jacked up, I could use the thermal loss that's going to happen naturally to heat up one side and quickly make an adjustment with my tweezers before it had ever gotten hot enough to release the solder on this side. So basically you learn over time how to manipulate the medium you're working with so that you can get better results. Alright, and then we're going to go ahead and trim this excess. Making sure not to cut our red line. That would suck. And we just have to get all those little pieces of the twisted pair to cut through, plus that little fiberglass material. But we've got it. Now, as you remembered earlier, we still have to do the ground lines. But you'll remember earlier that I spun this little thing on here. This is just its exterior shell, the housing that will now protect all of that wiring. And then it will screw over just like that. And that's going to be our connector. I will actually try to go through a full test on this, because we are making some assumptions about how the manufacturer wired it. That wrapped over the mic line, that copper that we unraveled, this non-twisted braid, who knows, maybe that's not actually the ground for the microphone. But I'm pretty certain it is. Yeah, and I did forget to rename this video, so for anyone watching the live stream, it'll have the wrong name on it, but I will fix that right afterwards. You know what? I bet you this. There we go. That'll make life a bit easier, so we can use that to just tie us in and through. So we took one of the ground lines and we put it through the little eyelet hole, which is what it's designed for. And we're going to use that to kind of keep our wire in place as we make it an anchor point for stabilizing this as it's connected. And we want to get this out of the way of our soldering iron before that line gets a boo-boo. Remember, this stuff is also enameled. And they used all enamel pairs on this, or twisted wires. And to make this work, we're going to have to add some flux, just that mildly activated rosin. Core is not enough for this enamel coating. All right. Alright, so I think actually that's a pretty good length already. It's not putting any tension on the other lines, but it's keeping it from, just kind of really getting out of where it should be. And so now we can take this, let's put our soldering iron up as we clean this off. Take all these pairs, and we're just going to wrap them and twist them like everything else. And then up, back, and over is all we're going to do to that. So we've taken that second line and we've just wrapped it over the back. Before we overheat that and cause that other one to melt and flow back through, let's do this independently. We'll get a good line of solder started on it, and then we'll be able to join it with the rest. Alright, so now we should be able to do our wrap over and have good contact for creating a solder joint. And there we go. Now, as these are enameled and they're not going to cause an issue touching each other, and they shouldn't be touching anything else because of the seal around them, we're not going to snip those just yet because I want to test this before we cut away and commit. And we're just going to use a cell phone and place so you can see I've now just connected it to a Galaxy Note 4. And I'm going to see if I can play some music. The phone will open up wearing gloves. There we go. We'll pull up Pandora. Okay, maybe Google Play Music. I'm pretty certain I have the app, but I don't see it. And I'm going to try to stick one of these headphones up to the mic and see if it picks up. Alright, so I have music through the headphone. And both left and right have audio. Now it'll be impossible for me to know if this is playing through the mic. I'm not even sure where the mic is on this camera. But that is working on both speakers, and let's do this. We will actually, on the phone, record something through, this should have a microphone. Record. Okay, Google, what is today's weather? And as you can see, I couldn't find the record app, which I could probably download one, but that's more effort than it's worth. But this thing has responded. In fact, using the camera above probably gives a far better confirmation than the microscope camera, because that's going to be quite zoomed in. So let's just put it here and we'll do this again. You can see that it is plugged in with the jack, which means that the mic is going to be overridden from the device, and it's going to be running off the mic incorporated inside of these headphones. And we're going to say, okay, Google. Okay, Google. Tell me yesterday's weather. Well, it just picked it up. Obviously, tell me yesterday's weather is not a command. What is today's weather going to be? It has some dots. Maybe I got to say, okay, Google again. Okay, Google. What is tomorrow's weather? I think what we're having here is a Samsung phones are crap if you don't buy a new one every year. And they like it that way, so it has hung up. We press it there, we end it. Okay, Google. What is tomorrow's weather? And there we go. So it is picking up voice, just the phone gets hung in suspension. It is probably past time for me to update, but I'm trying to wait for a Google Pixel 3. I want my next phone to have 8 gigs of RAM, and the Pixel 2 is definitely what I want. However, it didn't have that 8 gigs, so I'm going to hold out until they're next and then go. I mean, phones just really aren't getting the hardware upgrades that they used to, unless you're really into whatever the newest, latest, greatest camera is. But that, to me, by itself, does not merit $1,000 for a new phone. So, again, we've got these Bang Olufsen headphones, $150 retail. They broke shortly after the owner received them. They were part of a gift for their cell phone purchase. However, even as a gift, you still just wouldn't want to throw them away, and he didn't. So we're going to snip off these last little pieces here. The fact that everything is working means we were correct in that both of these are ground wires. And then, let's just go ahead and trim this guy. We don't need him. And it's just going to get in the way when we seal up and make some nasty little furlings that poke out. Let's do one last look at our solder joints. In fact, we can get a little closer now. I'm going to bring that zoom in and let's go down. I probably could have done that from the beginning, but then I would have had a really small area to work with. And I could have that center joint a little more shiny. I let it get a little hot and a little less flux, but it's still a good solder joint. I wouldn't consider that a dry joint, not yet. But it's not as shiny as the top and the bottom. But again, to reiterate, green wire, that is our left speaker. Red wire is our right speaker. Or did I just say that backwards? Well, it's left or right, one way or the other. This bottom pin is going to be mic. Now, there are some that are different where they don't use this back plane for the ground. They actually have 4 pins on this. And so the 3rd pin would be ground, and the 4th and furthest pin down would be your mic. So a little bit of a change, but not really a big deal to figure out if you actually have that one instead of this one. I prefer these ones with the background plane. It's one less item that is crammed into this little array here. So other than that, that is it. We can seal this up, and this customer will be happy to know that they now have their headphone and microphone set back that they can use on any device.